Okay, these are the notes for section 4.8, and we're continuing with this kind of thematic storyline surrounding the skills that we're going to be learning for this section. And so we're moving on from the pie factory to the frozen yogurt stand. And so the storyline says that the school jazz band is playing at Sweet Yo's frozen yogurt shop. It costs $5 to get in the door for the event. And if you'd like to eat free yogurt while you're listening to the band, you can fill your cup with yogurt and toppings for 40 cents an ounce, right? That's $0.4, so 40 cents an ounce. So it says write an equation that gives us the total cost in dollars of attending the event if you order Z ounces of froyo. So we're talking about the cost, right, for attending the event. So that cost then for attending the event is going to be a combination of how much you had to pay to get in, which was $5, and then let's assume you have some yogurt. So we're going to add on to that the cost of the yogurt. So if we're at 40 cents an ounce, or 0.4 of a dollar per ounce, so we're going to pay 40 cents for every ounce of yogurt that we have. So there's a function that provides us the amount of money we need, right, to spend at this event. So it is, if we write that with function notation, we would say f of z equals 5 plus 0.4z, right? It's our function of the money required based on the amount of based on attending the event and the amount of ice cream we need to eat. And then, you know, we've done this. We've done this before, right? We make you write a function, and then we ask you to use the function. And we could ask you to use the function two different ways. We could give you how many ounces of yogurt you're going to eat. So you're going to eat 14 ounces of yogurts and toppings. How much money do you need to bring? So if you are going to eat that much yogurt, then we are going to figure out that the amount of dollars you need, right, is 0.5 times, or 5 plus 0.4 times number of ounces, which is 14. And so we are going to need $5. And 0.4 times 14 is $5.60. This is $5.60 for the yogurt. So we are going to need $10.60 for the evening to go to this event. And then, you know, we've also done this, right, where we say, okay, let's use the same function in a different way. So now we're saying, hey, I only have $10 for the evening, and I want to go to this event. How much yogurt can I buy? So in that case, we're going back to that same function, and we're saying, okay, I know my output. So if we think about it in terms of input and output, the total cost of dollars is the output, and the number of ounces of froyo is the input. And so in question 2, we had the input and we wanted to find the output, and now in question 3 we have the output, right, the $10, and we want to find the input, how many ounces we can buy of yogurt with the $10 that we have. So we're being asked to solve for z, basically. And so we go through the order of operations, right? We say 10 equals 5 plus 0.4z, and we subtract 5 from both sides, right? That's the amount of money to get in. So I basically have $5 to buy yogurt, if that makes sense. And then we divide out the price per ounce, and we can buy then 12.5 ounces of yogurt. And so basically what we did is, like I said, we solved for z. We solved for Z, which was our input. And so let's just kind of, work through that again. Samara now has only $7 to spend. How many ounces can she buy? So she's got a bit less money to spend, right? And obviously she's not going to be able to buy as much yogurt. So we're just repeating that process, right? We're saying, okay, Samara's got $7, and she's still going to have to pay the $5 to get in, and she wants to know how much yogurt she can buy. So we're going to go through the same steps we did in question 3. She's basically got $2 to buy yogurt. And then if I divide by 0, I'm just going to rewrite this here so that I have the space to do my dividing. And she can buy 5 ounces of yogurt. Okay. And so what we're doing here, again, we solved for Z. Okay. And so what we could have done, instead of going through both of 3 and 4 separately and solving for Z twice, that's basically what we did. What we could have done is we could have taken our original equation, I'm going to box it in up here, number 1, and we could have solved for Z once and used that expression in 3 and 4. So let's do that now. We're going to take that original equation, so D equals 5 plus 0.4Z. We're going to leave the Z there. We're going to solve this for Z. Okay, so we're going to solve for Z. So we're going to go through the same steps. We're going to subtract 5. We just don't know how much money they're bringing, so this is going to be D minus 5 equals 0.4Z. And then we're going to divide by 0.4. 0.4. And so we have this expression that says this is going to cancel, right? This 0.4 on both sides. That's going to cancel. So we have Z equals D minus 5 over 0.4. Okay, so we solve this for Z. And that's just another function, right? And now what we kind of turn the tables. Now we can look at this function and say, okay, we can figure out, now everybody coming through the door, we can figure out how many ounces of yogurt they can buy, just based upon how much money they're able to bring to the event. And so we've kind of swapped, with this expression, we kind of swapped the input and the output. So now the number of ounces of frozen yogurt, it becomes our output. And the money becomes our input. And when we switch the output and the input, we call that the inverse of the original function. So I did function notation up in the original problem. So here was my function notation, right? F of Z equals 5 plus 0.4Z. So this new inverse, we could write that in function notation as well, and it would be F of D, because now our input is dollars, is D minus 5 over 0.4. So that is, oh, I used the wrong color. Hold on. I'm trying to color code things. Let's make this purple, and then I want to outline it in green. So this is now our inverse function, and it's solving for the other variable. And so if we look at this from an input-output perspective, using our function notation, now I'm kind of big picture here, right? I'm going back to question 1. We can say, well, our output is dollars, our input in question 1 is ounces. So let's go to let's go to, I think 3 here. This is I'm just deciding which one is kind of the best one to focus on here. Let's go to 3 here. We know that f of, nope, I take that back. Let's go to 4. No, let's go to 2, because that we have 14. So f of 14, whoops, f of 14 equals 1060. If we wrote the result of that in function notation, right? If I buy 14 ounces of frozen yogurt, I'm going to pay 1060. And so if we would reverse that, then the inverse would look like, and I'm down to number 5 now, f of 1060 equals 14 ounces. So if you notice that that inverse is swapping what we would call maybe the x and the y coordinate. It's swapping the output and the inputs, basically. So let's try that with 6 and 7, because 6 and 7 are kind of that way. So let's kind of apply this whole idea of using both of these, the original function and its inverse, and kind of mapping what this gets us from a function standpoint. So we've got Henry purchased 10 ounces of yogurt, 10 ounces of yogurt, and we want to determine how much he spent total. So it says, which equation should you use? Well, if this is the output, we want to find how much money he spent, then we should be using the function where we can find the dollars, right? So it would be 5 plus 0.4z. And so in function, I'm just going to write this in function notation, right? This is f of z equals 5 plus 0.4z. We are being asked, we know we're buying 10 ounces of frozen yogurt, so we are finding f of 10. And that is 5 plus 0.4 times 10 ounces, right? We're going to substitute in for z. And so 0.4 times 10 is 4, plus 5 is $9. So Henry's going to spend $9. So we have this notation that f of 10 is 9. Let's make that green. F of 10 is 9. Buy 10 ounces, spend $9. Okay, let's kind of reverse the roles here. So now we have this other student, Chandler. He spends $9 total. Which equation should you use to determine how much yogurt he purchased? So now we're using that inverse equation where we know how much money he spent, and we want to, the output now is determine how much yogurt he purchased, right? This is now the output. This is now the input. And so we're going to use that inverse function. We're going to use that z equals d minus 5 over 0.4. And 0 is a little sloppy there. There we go, it's a little bit better. So we know that we spent $9 total, and so 9 minus 5 is 4. 4 divided by 0.4 equals 10. So we bought 10 ounces of yogurt. Chandler bought 10 ounces of yogurt. So using that function notation, this would be f of d equals d minus d minus 5 over 0.4. And so in And then, you know, we do the same substitution. So we have F of $9 equals 10 ounces. So we have that switching of the inputs and the outputs. You know, so to speak, the 10 and the 9, right? The input here was 10, the output was 9, and on the inverse, the input is 9, and the output is 10. So that's the whole idea of an inverse, is the switching of the x's and the y's, so to speak, or the inputs and the outputs. And so the notation for that then is that if we have a function, and I'm running out of space here, but if we have a function, let's go back to the original function. If we have a function that takes the number of ounces and gives us dollars, then the inverse is going to be taking the number of dollars to give us ounces. And the notation we use is this notation. It's a little -1. And then we can switch the variables. So this notation, f to the -1, is called the inverse notation. And so in reference to the example above, it's we're going to, if we have the inverse, if we solved for the other variable, then we are going to get our inputs and our outputs to switch. So now that inverse is knowing the number of dollars we have and figuring out the number of ounces of yogurt we can buy. And so if we look at this from a composite standpoint, so remember the last example, the last section was dealing with composites. If I make a composite with this function and its inverse, then the cool thing is it gets back what we started. So in other words, if I take, let's take the inverse here, let's take this expression, the inverse, and put in to its input here, put into its input D, which is up here, which is f of z, we get z. So if you notice, like for instance, in regards to questions 6 and 7, if I take the inverse here, the inverse, which is this, so if I take f of 9, but f of 9, this is the inverse, so f of 9 equals 10, so f of 10, then I get 9. Oh, excuse me, then I get 10. So this f of 10 is 9, and the inverse of f of 9 equals 10. So I get back what I started with. I get back the variable I started with, which is kind of a neat phenomenon. If I take a composite here, like we did in section 4.7, then I end up getting back that original variable I started with. And that's actually the way you check to make sure that you have the composite, is you do this back substitution. And so that's the skill really that we're focusing on, is that back substitution to confirm that we have the composite. So we're going to look at that skill, and you're going to practice that skill in the checking your understanding. But we're going to look at that in terms of our learning targets here. The first learning target is writing the inverse function. So that's what we started out. That's what we started out doing in question. there we go. In question 1 is, I just got to put a number 1 here, learning target number 1, is we started out with an equation, and then in question 5, we started solving for the other variable. And so when we're writing these inverse functions, when we're writing spell writing correctly. When we're writing inverse functions, we want to basically solve for the other variable. So in other words, relative to our notes here, we had an f of z, which was 5 plus 0.4z. And then we solved for z. Actually, maybe I should say d, because that's really what we had to begin with. And then we solved for z, and we got z equals d minus 0.5 over 0.4. And so those are inverses. Those provide a pathway to find the other variable real easily. And so the inputs and the outputs switch. So inputs and outputs switch. So that's the first thing, is finding an inverse function, is just solving for the other variable. And then the other learning target then is to write a composition of f and its inverse, f minus 1, and this isn't, to do this is a confirmation of inverse. This is to confirm the inverse has been found. So in other words, if we write a composition, that means we're taking the inverse and we're putting in the original function, f of z in this case. Or we could do the other way around. We could start with the original function and put in the inverse. In this case, that would be the inverse is f of d, and we could do it either way. And so when we do that, in fact, I'm going to erase this and put the word or, because they're not necessarily equal. We could do it either way, and what we end up with is, so let's just try this. Let's start with the function, which is d equals 5 plus 0.4z, and we're going to put in the inverse right here. So we're going to substitute the inverse right here. And so what we're going to get then is d equals 5 plus 0.4 times the quantity, and that inverse is up there in question 5, d minus 5 times 0.4, so d minus 5, let me make that purple, d minus 5 divided by 0.4. And so I substituted in the inverse. I'm trying to color code here. There we go, substituted in the inverse. And so when I solve this now, what I get is, well, let's see here. Let's look at the brackets first, right? Order of operations. So I can cancel out a 0.4 and a 0.4. And so I get D equals 5 plus D minus 5. And I see that I have a 5 and a minus 5. So I end up getting D equals D. So when this is my confirmation of the inverse. So I'm confirming that that actually is the inverse. Because I got D equals D. I got a statement that basically says the independent variable maps back to the independent variable when I do that composite. So so what we're going to do and check your understanding is you're going to practice writing a function, writing its inverse, and then doing that verification. So this is like a number 1 and a number 5 and a learning target number 2. Okay, so write an equation that gives the money saved after working H hours, write an equation that gives H hours to save, and then verify that these are inverses using a composition. So you're going to practice that and then practice that numerically on the second check your understanding, and that should get you ready for the homework. And then, of course, you can verify the